So quite easy, right? Click on done and go to input. Wells data, no, we don't have well here in this case. So we can go to tank data, but you can also go to the tank input screen by double clicking on this element, this reservoir. Okay, so let's review it. Tank type oil, name, you can call it reservoir. Let's say the reservoir temperature 170 with initial pressure this, porosity, conduct water saturation, ask your geoscientist friend. Water compressibility, let's use correlation. Let's say we know that the gas cap downhole ratio is 0.05. Okay, you calculate it from the ratio between the volume of gas cap and volume of the oil leg. And then original oil in place, we use, volumetric information from our geologist friend as initial input, but later we can refine the number by performing matching. Datum depth is important here. Let's compare it with the GOC. The same with initial gas oil contact. So we use this as the datum. Okay, start of production here. And another feature we enable is monitor contact. So we can evaluate or we can observe the progression of the gas oil contact depth. Calculate bubble point pressure. Okay, so it has been calculated automatically. Water influx, let's say no aquifer, so none. Rock compressibility, let's use from correlation for basic. Rock compaction, inactive. Let's leave it as it is. Pore volume versus depth, this is very important. So let's see. Pore volume of -1 at the top of gas cap. Pore volume of 0 at the original gas oil contact. So pore volume of 0 must be at 4,509 because this is the GOC. All right, and then this, the fraction at each TVD through vertical depth, and lastly, the value of 1 at the original oil-water contact. But although we have original oil-water contact, we do not consider the water layer below our reservoir as the aquifer. So that's why we can use none for water influx. Okay, so that's it. This is very important. You can follow me just for exercise and learning. And relative permeability, let's say we have SCAL data, spatial core analysis. We use relative permeability from Corey function. So we need to provide the residual saturation at endpoint and also the exponent. We use default value for water sweep efficiency and gas sweep efficiency. And we can plot like this. Okay, we can plot like water relative permeability versus water saturation and oil relative permeability versus water saturation. Okay, and lastly, well production allocation. Let's start from basic. We do not involve well models, so we leave it as it is. But we have production data. It's quite simple. So we have time, reservoir pressure based on monitoring, cumulative oil production, cumulative gas produced, and yeah, we can leave the other blank like this. So we can plot. We have the reservoir pressure and cumulative oil production evolution. Okay, so we can close it here. Now let's go to history matching. History setup, 15 days, just leave it as it is, base case. Story matching analytical method. Okay, let's say we haven't reached the matching. To perform the matching, it's very simple. Just click on regression.